If you see a question like this, are you able, using what you currently know, to solve for the missing side x? It's not a right angle triangle, so that eliminates being able to use Pythagoras' theorem or a primary trigonometric ratio. And in order to use the sine law, we know we need pairs of opposites. The trick here is that this is one pair of opposites, but this contains the variable for my missing side. So if I were to set this up, x over the sine of 95 equals, I now need another pair of opposites. Even though I know this side length, I don't know the angle opposite. Even though I know this side length, I don't know the angle opposite. So the sine law is not able to be used in an example like this. But thankfully, there is another law that will help us find missing side lengths and missing angles in triangles, and that's what we refer to as the cosine law. The cosine law can be used when we have two cases. If we're given all three side lengths in a triangle, or if we're given two side lengths and we know that angle in between the side lengths, those are the two scenarios in which the cosine law will work to find our missing measures. We cannot use the sine law in those two examples, but we can use the cosine law. All right, so take a look at the triangle here. So this is not a right angle triangle. We have an oblique triangle. And we know that this is side C, this is side A, and this is side B. This is our cosine law, and you'll notice it comes from a combination of both Pythagoras' theorem as well as the cosine primary trigonometric ratio. The one thing that you do have to watch when you're using it is that this is referring to an angle measure because it's a capital letter. We know that if we are going to put that angle measure there, it means that we're solving for the side opposite from it. These letters are interchangeable. It does not matter the order in which we add two sides. It doesn't matter the order in which we multiply two sides. But what you have to remember is the angle that you put there means that we are now looking for the side opposite from it. The other thing you want to keep in mind is if we are given all three sides and we're trying to calculate an angle, you want to make sure that you calculate the largest angle first if you're using the cosine law. We want some understanding as to where this cosine law comes from. So similar to with the sine law, we have an oblique triangle here, and I'm just going to label it angle A, angle B, angle C, which means this is side length B, this is side length C, and we know the base of the triangle is side A, but I'm going to actually put it down here because when we break this into two right angle triangles, so we can use a primary trigonometric ratio, this is now the height of my triangle. I'm going to, with the cosine law, call the base of this triangle X, and I'm going to call the base of this triangle Y, just for the purposes of developing this. All right. Because we're going to use Pythagoras' theorem here, and we also know that h is the one letter that does not appear in our cosine law, I'm going to set up these two triangles relating the sides with Pythagoras' theorem. And I'm going to do it in relation to h because that's the one we ultimately want to eliminate from our proof. All right, so I've gone ahead and set up Pythagoras' theorem for those two right angle triangles. Because h does not show up in the cosine law, that's going to be the variable we ultimately want to eliminate. Because c on this left triangle is my hypotenuse, you can set up a squared plus b squared equals c squared if you'd like. But because I'm ultimately trying to isolate h squared, I'm subtracting this side from the hypotenuse. And then similar on the right-hand side, it's ultimately h I want isolated, so I'm going to subtract this side, the square of this side, from the square of the hypotenuse to get that isolated. And then remember back to the sine law, we know if two quantities are equal to the same amount, therefore they must equal each other. That's the transitive property. So because h squared equals this, I can literally substitute this piece in the place of h squared. And so now we have c squared minus x squared. This piece here is equal to what h is equal to. And then I'm going to isolate c squared here in order to get this piece like that. So again, you always want to go back to what does the cosine law look like? And then a lot of mathematics is, can we manipulate it to get it into the form that we want? So instead of a squared, which is the ultimate side that we were solving for with the formula that was first given. I purposefully want to set this up in relation to c squared, just so that you can see how those variables relate. Two other variables that don't show up in the cosine law are x and y. So let's take a look at those ones. So going back over to our triangle here, we can see that if we add together x plus y, that gives us that side length a in our triangle. So x plus y is equal to a, and I'm going to isolate x, so I'm going to subtract that y to end up with this equation. And then because x is equal to this, again, I can substitute what x is equal to in the place of x. So now the only variable that we need to ultimately get rid of is that y. And now we're going to simplify. This is a binomial squared, which we know we need to FOIL. So we're going to do that now. We're going to say, okay, c squared equals, so remember, square the first term, double the product. If you want to go to the side and FOIL those out, feel free. And then we still have that plus b squared, and we still have that minus y squared. And then we can see that if we collect our like terms, positive 1 and negative 1 are going to cancel out. So we are left with now that c squared equals a squared, and then I'm going to rearrange this. I'm going to take this b squared here, and I'm just going to move it over here to get it more into the format we want it. So plus b squared, and then I'm going to put that minus 2ay. Okay, so this is looking like our cosine law. We know that we have the square of one side plus the square of one side minus 2a, and what we now need to get rid of is this y that doesn't show up in the original formula. So we're going to go back over here and we're going to say, okay, how does y relate in this triangle here? As how this is the cosine law, you are probably waiting on the edge of your seats for cosine to appear, and here it comes. So taking this triangle, right angle triangle, on the right-hand side of my oblique triangle, I'm going to take angle C. So I put theta there just so we can see this. We know the cosine ratio is the adjacent side divided by the hypotenuse. If this is my reference angle, this is my adjacent side, this is my hypotenuse. So we're going to set up our primary trigonometric ratio. The cosine of angle C is the adjacent side divided by the hypotenuse. And again, y does not show up in this ratio. If I want to get y isolated, I'm dividing by b. So to isolate, I'm going to multiply by b, and then I'm going to do the same thing over here. So we know that b times 1 over b is just 1. So I'm going to have b times the cosine of c, and that is equal to y. And again, because y does not show up in our final formula, I'm going to take what y is equal to, and I'm going to substitute that into the place for y. So y is equal to b times the cosine of c. The order of these variables is purposefully different than those on your formula sheet, because what you need to remember is if we are looking for side length c, the angle that goes into the formula has to be the one opposite from it. Again, the order in which we add these two sides or multiply these two sides does not matter, but we need to make sure the one angle in our formula is the angle opposite from the side that we're looking for. Example of where we could use the cosine law. We have an oblique triangle and we do not have pairs of opposites, so we can't use the sine law. However, we have this pocket here. If we know an angle and we know the two sides lengths that make up that angle, that's where we can use the cosine law. So because we're looking for our third unknown side f, when we set this up, just remember the angle we use is the angle opposite from f. So I'm going to set up here, we're looking for f, and remember this is squared, is equal to the one side squared plus the other side squared minus 2 times the first side times the second side times the cosine of that angle opposite the side that we're looking for. So we're going to set this up, and then we're going to put this in our calculator exactly the way that we see it. Make sure that you're in degree mode, and we're going to go across here and we're just going to type in 25 squared plus 30 squared. And then this is a minus 2 times 25 times 30 times the cosine of 40, enter. Okay, so that's going to give us f squared. So I know the value of f squared is 375.93, etc. And remember, we're not going to round this off yet. Now, that gives us f squared. We want just the side length of f. So we know that in order to get f, we can eliminate a squared by square rooting. So we're going to square root this value. So in our calculator, we're going to go second function and then press the squared button to access that square root. We're going to go second function answer to put that whole value in. And there you go. So f is equal to 19.389. And if it doesn't say, we tend to round side lengths to the nearest tenth. Because this is in the 10th position here, there's a number that's greater than 5 that follows it, which bumps up that 3 to a 4. And the units on this are meters. So f is 19.4. The next example is very similar in that we have a triangle and we're asked to put some fence around the perimeter of the triangle. So we already know these two side lengths. We need to calculate the measure of the third side length and then add them together to get that perimeter. I'm going to get you to pause me and I want you to see if you can set up the cosine law. We know it's the cosine law because it's not a right triangle and we have that pocket. So we're able to use the cosine law for this one. So you try this and then come back and see what you get. All right, how did you do? Because we're ultimately looking for a, I'm going to add the squares of my two sides together, and then I'm going to go minus 2 times the one side times the second side times the cosine of that angle. We get this value when we type it into our calculator, but remember that's a squared. To find a, we need to square root that. So that gives us just the 22.08. And then because we're looking for the amount of fence, we're going to add all three side lengths together. And then I just rounded those to the nearest tenth. The cosine law can be used to find a missing side length if we have that pocket in our triangle. It can also be used to find a missing angle measure if we know all three side lengths. So what we're going to do now is take this formula and see if we can rearrange it to solve for that missing angle measure. The first thing we do when we want to isolate something is to remove any pieces that we are adding or subtracting. So you can see this is all multiplying. We're negative 2 times b times c times the cosine of a. So I want to start by getting rid of those two pieces here that we are going to be subtracting. So I'm going to subtract them from this side here. And when we do that, we're going to have a squared minus b squared minus c squared. And that's going to leave us with negative 2bc times the cosine of a. And again, I'm going to now take a look and say, okay, if I want to isolate this cosine of a, I need to get rid of that negative 2bc. We know we can get rid of it by dividing that out. So I'm going to divide out negative 2bc on the one side, and then to keep it balanced, I'm going to divide it out on the other side. When we do that, we know negative 2bc divided by negative 2bc is 1. So we are left with a squared minus b squared minus c squared divided by negative 2bc is equal to the cosine of a. Okay, so we now have the angle isolated. The only thing is we ideally don't want to leave a negative in the denominator. So I want to move that negative up to the numerator. So when I do that, I'm going to bring up the negative, and then that is going to get applied to everything in the numerator. So we're going to multiply it in to get rid of those brackets there. All right, so when I distribute that in, it becomes a negative a squared plus b squared plus c squared, a negative times a negative is a positive, divided by 2bc equals the cosine of a. Okay, so this is pretty good. We have the angle A isolated. The only thing now is mathematicians don't love a negative leading coefficient. It just doesn't look quite as pretty, so they kind of tuck it behind. So we're going to just rearrange these and move this term to the back, kind of to hide that negative. So I'm going to leave that b squared out front, plus c squared minus a squared, and we're going to divide that by 2bc. And we can use that to solve for a missing angle. And that's the final thing we're going to do today. In our last example, we are trying to find the measure of angle A. This is my angle A, so I'm going to put a theta here just to make it a little bit easier. When I set up the cosine law, we want to make sure that angle A is opposite from side length A. That's the one thing we have to keep in mind. All right, so I'm going to just write out the formula here. We know that the cosine of angle A is equal to one side squared plus the other side squared minus the side opposite from that angle. And then we're going to divide that by 2BC. Okay, there's a couple things you need to remember. Number one, please make sure that the side we subtract is the side opposite from the angle we're looking for. The second thing is when you put this in your calculator, you have to put the denominator in brackets because we want to divide the entire numerator by the entire denominator. If you do not put it in brackets, you're going to get a wrong answer. So just make sure you remember to put those brackets there. All right, so now substituting in, we know the cosine of A is, so the order of those other two sides doesn't matter. So it's going to be one side squared plus the other side squared minus the side opposite angle A. That's where that 11 has to go. And then we're going to divide it by 2 times that first side times that second side. And again, you have to make sure that you put that in brackets. So when we go to enter this, we're going to go, now you have a choice. You can either put the numerator in brackets as well, or just press equals after. So we're going to go 7 squared plus 9 squared minus 11 squared. And then you're going to bracket that. We need to calculate that whole value, or you can press enter, it doesn't matter. And then we're going to divide it by, you have to put brackets, 2 times 7 times 9, close the bracket, and that gives us that cosine ratio. So we know the cosine of angle A is that 0.714, and we're going to keep that in there. So this is the ratio of the adjacent side divided by the hypotenuse. Remember, to find a missing angle, that's where we take the inverse. So we're going to go now second function cosine, second function answer equals, and when we do, we get that angle measure of 85.9 degrees. Because we tend to round angle measures to the nearest degree, unless it specifies otherwise, this is a 9, which bumps this to a 6, so I end up with angle A measuring 86 degrees.